Can someone of you test that it's working live stream? Can you go to the course page and there is a link for the remote students? Yep, it's working. Okay, that's good. Okay, I think it's time to start with today's lecture. So last time in the second lecture we learned about object-oriented concepts, what an object is and what the class is and how you can use the objects and classes and some of the basic principles behind object-oriented programming. In today's lecture, we will learn another important and useful, two important and also related concepts known as with the name of Java generics and collections. So as you can see here, this is something that we will be talking about today. And before that, last time there was a problem with the live streaming. But I hope apparently it's working today on my system, so hopefully it should not be a problem. So we will begin with Java generics. We'll have a quick introduction of what Java generics are and why we need them. And then we will learn about generic types and parameters, so how you can define generic types and use them. We'll also learn some of the features regarding Java generics, particularly the wildcards, how we can use wildcards. And then we will, in the second half of the lecture, we will learn about Java collection framework. So we'll get a quick overview and we will look at some of the important interfaces and implementation classes and how you can use them. So can someone discuss or tell me about Java generics? Do you know already? Any one of you? Yeah. Sorry, can you speak a bit louder?
In generic, you specifically define the type of the object.
Uh-huh.
So if you want to define, if you want to make an array of integers, you specifically define its integers, then it can only take integers. So similarly with strings.
But is it not the same, like whenever you want to declare an array, you need to specify the type, always? Because Java is, I think it's a strongly typed language, so you always need to define the type of your object or even the primitive data type.
Yeah, there are some like interfaces, like sets or something like that, in which you have to specifically define which object it should handle. So over there,
yeah, that interpretation is more appropriate. Java generics, it's a feature that was introduced in JDK 5, so after Java 5, from Java 5 onward. And what's important about the Java generics is that it enables you as a programmer to write a code that may work for multiple types of data. And we will see how we can write a code or an algorithm or a method that we can use to work with the multiple types of data. For example, if you want to find out a number of elements in some array of strings or integers, or if you want to perform an operation on different types of data. So instead of writing a separate methods, Java generics allows you to write a method, and then at runtime you can specify the particular type for which you want to use that code. This we perform by defining generic types. And when I say generic types, it means classes and reference and interfaces. And then you can also define generic methods. So we will see what these two are. But before moving on, maybe a question comes in mind that why we need Java generics. So there are two primary objectives for which we need Java generics. The first one is that it allows the implementation of generic collections. Before JDK 5, there was collections features available in Java, but those collections were non-generic. And when we say non-generic, it means like the collections before Java 5, they were using objects class to collect or aggregate the data. If you have more than one data items and you want to have something, a program that want to manipulate that data, so you could create a non-generic collection, for example, array list. But the problem with that kind of, it will be much easier to understand if we look at the example over here. How this one over here. So, for example, we know that one of the collection class or some of the basic collection classes are the list, array, and list. And the problem, if you see over here, is and the object class, use of the object class in non-generic collections allows us that we can insert any type of object, whether if it's an integer, if it's a string, or if it's float or double, or maybe some reference type. So here we say that list, and that points to a new array list. And we know that in array list we can add elements of different types, and the size of the list will grow dynamically. So if you see here, we have a list.add method. So we add an integer value, and we add then a double or a float type of a value with the decimal point, and then at the third point we add a string value. So we can add different types of data in non-generic collections. So this kind of collection you can also call heterogeneous collections. But the problem is when we iterate on these values, we need to explicitly tell that which kind of object we are returning from the list. When we are inserting, there is no problem. But when we want to retrieve some element from non-generic collections, we have to specifically tell the compiler that that what kind of object we are returning, because the method available to retrieve the elements or to traverse the elements is through the iterator class, through the iterator object. So every the collection classes or types, they provide you with this method, iterator method, which returns an iterator object, and an iterator object allows you to traverse the different, to cycle through the different values or the items in a list or in a collection. So when we go here, we say that we want to return to access the next element in the. So the next method gives us, it starts from the beginning of the collection and returns the first element that it finds. So here if you see that, since we know that the first element we added was an integer, so we have to the first element will be the integer type. So we have to explicitly write this. But sometimes you might forget the order in which you have added the elements. So for example, we have added the first element was integer, and then there was a decimal and double value, and then the string value. But if you see, what we are getting here is we are getting integer, and then we are getting a string. We are skipping up the decimal value, but the compiler, the program is the compiler is not showing any error. There is no syntax error. However, when you run this program, due to this problem with this, because you have returned the integer value, and the next you are trying to typecast a string value. However, the value is of type float. So it means that every time you have to take care of your types, and you have to explicitly downcast or cast the values to those appropriate types. Otherwise, you will get to a java.lang.class cast exception. So this exception is because there was a double type of a value, but since we have skipped this one and tried to because iterator.next is returning a double value. However, we are forcing that, we are expecting that, we have mistakenly thought that it will be a string value. So that's why we got an error over here. So if you want to fix that error, maybe you can say like double d is equal to, and then you have to specifically tell the compiler that the next value that we are returning is of type double. So for a time being, I just want to comment this thing. So now if we run this, it should be no problem. Yeah? But then another thing is, just to see the difference, you can see this more clearly maybe in this code. Here we are trying to, we say that we have created another array list of subjects in which we add the value of string type, list the subjects that add first. But what we are doing here, we are doing something wrong, that subjects dot get 0. We know that the value in the subjects is of type string, but we are casting it to an integer value variable, but which is not possible. However, if you see that the Java compiler is not complaining anything. So because this is why this is because that due to this because use of this non-generic collection which allows objects of any type, you can insert the elements of any type inside it. But whenever you will return the object, it will return you an object of type java.lang.object, which is a superclass of all the objects. But then you have to explicitly typecast it into a right type. So you have to take care of this by yourself. So, but if you use the generic instead of using this non-generic collection, if we use kind of generic feature, generic list, then when we try to do this kind of thing, the compiler will complain. We will see how. So, for example, we have, if we go to here again to the same thing, and if we now make this list from non-generic to generic, and for generics we use this angular brackets. So, and here we need to specify what type of elements we can add in this list. So, since it's a list of subjects, so we assume that this list will contain string type values, and we tell this to the Java compiler that in this list we are going to have a list of string type of values. Now, if you see, as soon as you have specified the string here, you've got a red line over here, kind of an indication of a compile time error or syntax error over here. So these are the two important things due to that lead us. This is the one thing that why we need enable implement. The first feature was enable implementation of generic collection. So the Java generics feature allows you to make your non-generic collections to a generic collection, and its other important feature is that it provides you type safety. What does the type safety mean? Type safety means a program, we can say that a program is a type safe if it compiles without errors at compile time and warnings. So we can say that it will not raise any unexpected class cast exceptions at runtime. And so, and you can, and to achieve this thing, Java generics is a key feature. You got the idea? Okay. So moving forward, yeah, as we said earlier, why generics? It's an alternative to Java generics is to use object class. So before the Java generics, we were using the object class, but the problem with the object class was that we need to explicitly cast the values. Otherwise, we will get into the class cast exception. So here is an example. So for example, if you have defined, this is non-generic version. So you want to create a container which can contain the value, a container class, which can, as a list or as a container that can contain or hold objects of any type. So for this feature, we say that the values will be contained in a type of object class or reference. So as we know that the object is a superclass, so it can refer to any type of objects or references. And then it has just the two getter setter methods. So if you want to use this class, of course you have to create a new object, and we can say that okay, object container, and we want to have like one container for string type of values, another container for integer type of values. So we specify here integer container, but then since this is not like supported by Java generics, we have to explicitly, whenever we want to access a values, we have to typecast ourselves. So here we are, because it's a string container, we have to typecast ourselves that it will return a string value. And here, because we know that this is an integer container and it will contain integer value, so we have to explicitly typecast by ourselves. So, and another thing is, in non-generic Java, if you create a collection of elements, then you have to get that collection of elements for various types. For example, a collection of integer, collection of string. You have to create a separate class for each type of that you want to support. So implementing a separate collection class for each element type is not a good idea, because you have to do the same thing for multiple types again and again. So what will be the optimal? The optimal solution will be to write something that applies generically to multiple types, and then you can provide the type parameters at runtime when you compile and when you execute your program. So depending on your requirements, you can change the type, and your code will be at runtime will be dynamically adapted according to the type you specify. So this means that generic allows us to implement one generic type that can be instantiated for a number of different types. So how can we do that? This is a general syntax. So to get a generic class, this is same like we have a normal class definition. We have here access specifiers, public, or you can maybe omit it. And then you have a class keyword, class name. But after the class name, we have this angular brackets where we specify the type parameters. And the type parameters are, there could be more than one type parameters. And the type parameters are the values of the primitive types or the different types that you want to instantiate a generic type. So that's how you can, and if you look at the example, the same object container, we have now transformed that object container into a generic container. And to do that, if you see the difference over here, we have written like a generic container of type T. So here we have specified a type parameter, and then instead of using the class object, we are using this parameter to specify the type here. And then at the runtime, when you create an instance of this generic container, you can specify the type for which you want to use this code. If you want to use it for string class, you can specify the string, and in that case, this T will be replaced by the string type. So if you use the string here, all the T occurrences over here in the code will be replaced by the type argument that you provide at the time of creation, instantiation of that type. So what advantage we get over here? If you see over here, since we have not specified that generic container of type string, and then we have created the object, and here we have put some value. And here if you see that now when we are calling this get object method, we don't need to tell what kind of object is returning here. Because why? Because we have already specified that this container will have string type of data. And by specifying this, it also restricts that you can only set this, you can use this set object method only with the type string. You cannot add any other type of data over here. And same, so now you have used it for string type values. If you want to use it for the integer type or some other type of value, you can, when you are creating the object, you can change the type parameter over here. And if you change the type argument, you will get a new type of. And just to look at some examples how this works, I have something over here. So generic container. This is the code for the generic container, and then we also have a code for object container in this class. So you will get the code as together with the lecture slides. So it's the same that you shown in the lecture slides. So if now we see here the object container, on these two lines we are using the object container, which is a non-generic, and we are using the typecasting thing over here. But then on the next part, since we are using the generic version, generic container, and we have specified the type integer or string, So then when we get the object, so you can see the difference between this and this method over here. Here we are using typecast, and here we don't need to typecast because we have already told the compiler that through the generic features. Okay, and then there is another example you can use where we have implemented a generic stack class. I think you already know that what a stack is. A stack is a list of values in which we get the values in a last in first order. So it's a data structure, and we have created here we use the type parameter. We have created this stack instead of non-generic. When we specified that this stack need to be generic, so we specified this using the type parameter t, and then we have defined the different parameters, the different methods over here. So this is a constructor. Initially, it constructs the size stack of size 10, and and then there is another constructor where you can specify the size, and then it has just the two methods, push and pop. The push will set a value inside the constructor, and pop will get you the value in return. Okay, so basically this is just the same code. Now, how can we use this stack class? We have defined just one class, and we have not specified the particular type, but rather we use the type parameter. Now we can use this stack class to get a stack of type integer, to get a type of double, or any type you want. So if you see that here we have 3 stacks. In the int stack, we can only push the values of type integer. If you try to push any other type, you will get a syntax error. And in the double type, you can only push the decimal point values, and in the string stack, you can only put the string stack values. So this is how you can, get benefit from the Java generics, that you can define a generic type, and then you can instantiate it with the different type parameters. And the type parameters and the type argument. What is a type parameter? It's an identifier that that you specify within the Angular brackets, and you can specify one or more than one type parameters, and these are used to specify generic types, and you can use them with both class, interface, or method definitions. And and the general rule is you can use any identifier other than the reserved words or the keywords in Java. The general convention is that the type parameter should always be a single letter and in capitals. But you can use even if you put more than one letter or a small case, there will be no syntax error. But this will be against the standards convention that are used in Java. So it's always recommended that you should use for the type parameter, you should use a single letter, and that letter should be in capitals. And normally, if it's like if your type parameter is pointing to a type, we use T for that. And if it is pointing to a key value pair, we use the convention is that you use K and V, K for key and V for value. And if it's pointing to an element type, and then you can use the letter E. Okay. And then another thing is the arguments. The difference between type parameters and type arguments is the same as the differences between the method parameters and the method arguments. The method parameters are the parameters that you are the different variable that you have specified in the method definition, and the arguments are the values when you are those variables that you pass to the method. So same is like here. So for example, we know that if we have stack T, here T is the type parameter, and integer, string, these are the different arguments, type arguments that you use to instantiate. Moving forward, that was the generic types. And then another concept is generic method. Generic method is a method that can operate on multiple types. Okay, it's the same like that we have a generic class, but sometimes instead of having the whole class as a generic, you want to have only a method to be a generic. So you can have a generic method inside a non-generic class. So and that's if you want to have a block of code or statements that can operate or execute, manipulate on a different types of data. And how you can define a generic method. Here is the general syntax. And the important thing to remember here is that before the return type of the method, when you are defining your method, before the return type, you need to specify the type parameter here. All other definition is almost the same. If we look at the example here, so we have on this side we have a non-generic method, and on the right side we have a generic method equivalent of the same. And what does this method is doing? This method is taking an array of string, and then it takes a string value and find the number of occurrences of that element, the string value that you passed in that array. For example, if you have a array of names, and if you want to find how many times a specific name is there in that array, so and if you just iterate through the array, and then you compare the element with the value that you passed and have a counter variable. But this method will work only on type string, because you have specified a non-generic type here. It cannot work, you cannot use it for any other type. You cannot use it for integer or your own some reference type or double or boolean or some other. But if instead of this, if you want to have the same functionality for different types, you can use generic method. And as we know that before the return type, we need to specify the type parameter, and then you will have to specify, you have to, the only thing that we do is that we change this string type with the type parameter that we used here. And then if you go into here, you can use it for the integer types, and you can also use it for some other types. So if we look at an example code here, so we have, here we have a non-generic method which is just count, and then we have another method which is a generic one, and here we have string hello world, and then we have integer strings, and we want to find that how many times in this hello world string the letter L has been appeared, and in this integer array we want to find how many times the integer 0 has been appears. So now if I comment this block, which is a generic method, you will see on this line there appears an error. Why? Because you are trying to call a count method. Both these methods were with the same name. It has the same name, count and count. However, you have defined this count method that will work only with the type string. You cannot use it with the type any other type. Doesn't matter if it's a type integer, decimal, or some other reference type. But on the other hand, if I comment this, and then I just uncomment this one, you will see that you can use this method both for strings and also for the integers. Okay, even if I have removed the method that was defined for the string type, we are still able to use this count method. And if you run this, it will just tell you how many times. Proceed. So where is the error? Should not be the error. Okay, throw the exception. Yeah, it's because we have now removed that thing. Okay, I hope the example helped to understand what the generic method is. But if you have questions, of course, you can post on the forum. And then the next thing is that sometimes we want to restrict, instead of specifying that the type parameter, that we want to specify that only this type or subtype of this type could be used with a generic method. in that case, we can specify, we can make the is a relationship with the type parameter using the extends keywords that we used last time in the object-oriented language for the inheritance. If you want to inherit from one class to another class, we have to extend a class. And similarly, we can, if we want that the type could be either a super type or any of the subtype of that type, then we have to specify this using the extends keyword, and then we have to provide the superclass name over here. For example, if you want this number stack, the stack class that we have defined already, if you want that stack class to only work with the type with numeric values only, then instead of, if we go here, now we have no constraints on the tree here. The tree could be referred to any, can be used for any type. But if you want this stack to use only for the type numeric types, doesn't matter if it's an integer or if it's a decimal point or a double value. So if you put it like here, extends number, and save this one. Now if you go to the stack manager we are using here, when you are declaring it for the integer type, it's okay, because integer is also a subtype of number class. Double is also a subtype of number class. But when you try to create a stack of type string, it complains and it gives an error. It says that bound mismatch, the type string is not a valid substitute for the bounded type parameter t extends number. Because since string is not subtype of number, and that's why here is this error message. So if you want maybe one thing that you can do is that either if you want, you can create another class maybe. If you want to have a stack which can work for any type, you can keep this unchanged, and then maybe if you want to have a stack that works only for a specific types, you can have maybe another class. Okay, so this is how you this is called bounded type parameter. So when you have specified restrictions that your type parameter could be either a subtype or some specific type or its subtypes, then you can define this using the extends keyword. And if this is the same that we have already looked at as an example. And then there is another important thing to know about the generics and the subclasses. We know that the subtypes are that if class B is a subtype of class A, if the class B extends the class A or B. So, and from the previous lecture we know that from the Java library we know that integer and double both are the subtypes of number. And according to the Java, because array list and list and collection and iterable, these are all the part of Java collection frameworks. We will learn about this in the second part. But just for now, you just remember that array list it's a subtype of the list interface, and the list interface is a subtype of collection, and collection is a subtype of iterable. And then the Java has this substitution principle for the subtypes. And what does this substitution principle say? It says that a variable of a given type may be assigned a value of any subtype of that type. Okay, so if you have a variable of a type, you can assign to that variable the value of same type, and also you can also assign a variable of its subtypes. And then a method with the parameter of a given type may be invoked with an argument of the type that has been specified in its definition or any of its subtype. So that's the substitution principle. And if we look at now here, we say that list number is equal to, we declare we have a numbers reference type, list type with the name of number, and then which points to which refer to array list object. And then if we add the values numbers.add, which is of type value of, that's okay, because both these are number types. However, now there comes a question. The question is, we know that integer and double both are the subtypes of a number class. So do you think that the list, the list of integers with the generics and the list double, are these two are the subtypes of list number? No. Why? The integer and double are subtypes of number. Okay. So does this principle also applies on parameterized types? Because these are the parameterized types. When you have parameters with the types, we call them parameterized types. The answer is no, because this substitution principle, it does not work for parameterized types. It only works for the ordinary primitive types or your reference types. So if you have a type defined with the parameter values, so then this principle breaks out. So you cannot, in that case, you cannot, you cannot use the substitution principle. We can look at this example over here now. We have list of integer, and we have added the values over here. But then, instead of having an integer type of reference variable, we have its super type. According to the substitution principle, the super type variable can point to the objects of its subtypes. But here you will get the compile time error because the substitution principle doesn't work. However, and this is only for the collection types. But if you look at for the arrays, because arrays are similar to the collections objects, you can use arrays to store more than one values as a collection. But this principle works, the substitution principle is completely fine for arrays. So if you have an array of integer and then you have an array of doubles, you can assign this array of integers to a number type variable. Okay. So that's the difference that you should need to remember between when it comes to the parameterized types or the Java generics, that the substitution principle in general doesn't work. But we have another thing that we have is a wildcard. Wildcard is a type parameter in the form of a question mark, and the question mark points to the unknown type. So it means that we at some time that we want to have a code that we don't know, that could be adjusted according to the different values that we use at runtime. Okay, and this wildcard can be used in different situations. It can be used as a type parameter. It can be used as a field of a class or a member attribute. It could be used as a local variable in a method or any other block of code. And you can also use it to return type. But a general advice is that you should not use it for a return type, because it's not a good programming practice that you have a method which is returning something, but you don't know what type will be returning over here. But according to the syntax and the specification, this is you can use it as well. And we have the three types of wildcards. We have upper bounded, and then unbounded, and the lower bounded. I think it will be more easy to understand the concept of these wildcards if we look at an example over here. So we have a class with the name of wildcard demo, and we have three different methods. The first one is demonstrating the upper bounded, and if you see over here, we have a method with the name of sum. This is not generic method, because if it is a generic method, then we have to specify the type parameter before the return type. So this is just our ordinary method. And if you look at here we say that list extends number. So this is when you say that a parameter which could be of type, I mean, if you want to allow any type, maybe we can begin with an unbounded wildcard. An unbounded wildcard, you just specify a question mark. You don't specify anything else. So it means this print data, it could get unknown type. The type is not specified here. And so this means that you can use it to print with any kind of data. And if you look at here now, in this method, main method, where we are calling this print method, maybe not, it's on the bottom, yeah. In the main, we have an integer list and double list and a number list, okay? And we can use this print list method on all these different types. We can use it on integer, we can use it on number type, we can use it on double, and we can also use it on a string list. But if you want to use it only for a specific type, and if you want to say that this method will be used only for a specific type or for its super type, not subtype. If you want to use it for a super types, you want to allow that the parameter could be either of the type that you have specified or of its super type, then you will use the keyword super and specify the type. So if you now look at here, we have this integer sum, and we are calling this integer sum with the variable of type int list, which is of type integer. This is okay. But if you try to call on this method with the double type, with the double list, on this line you will get an error. Why? Because double is not a super type of integer. The super type of integer is number. So you can use this method either with type integer or with type double, no other type. Sorry? Other, yes. Because it's a lower bounded wildcard. It can be used only with the type or its super type. You can remember it from the word super. So you can use this method with the arguments of type either integer or its super type. And the last type we have is upper bounded wildcard. And in the upper bounded wildcard, we use the keyword extends, and in this case you can use the type or any of its subtypes. So it means that we can use the sum method with the values of type number or with any of its subtypes. But in this case, we can use with the type or any of its subtypes, the different, super types. This one you can use with the subtypes, this one you can use with the super types. So that's the difference between the two. Okay, that's the description of that. Yeah, so this is unbounded wildcard when you put just only the question mark, so there is no bounds. If you put extends, you have specified the upper limit, so what type you can use it, and then the subclasses you can specify. And when you use the keyword super, yeah, you specify that you can use it with the type or any of its super types. So if you use it with, for example, if you have, this is the same method in sum, and if you use it with, if you try to use it with the type double, you will get a compile time error. Okay. So I think it's time to have a 10 minutes break, and then we will continue after the break. Okay. Okay, I think it's already 10 minutes. So yeah. So in this second part, we will look at the Java collection framework. And the collection framework is basically it's a library interfaces and some classes that are provided by the Java to store, retrieve, and manipulate, and to perform different operations on aggregate data. So what does the aggregate data? It's basically, as the name says, collection of data. So it's different kind of data that forms natural grouping that have some kind of association. So for example, maybe books in a library, or players in a team, or maybe members in a club, or students in a classroom. So all these kind of things that form a natural order. We can say that these are like collections. We can represent them using the Java collections as well. So here is some hierarchy of interfaces and classes provided by this framework. As you can see at the top, it's the iterable interface. So most of the these of the classes that are represented in this hierarchy, they are interfaces, also abstract classes, and some the concrete classes. So mostly the classes on the top, they are abstract, or the interfaces, both interfaces and in the middle they are more like abstract classes, as you can see, the abstract list and abstract set. And then at the bottom we have more concrete classes over there. And the iterable, if you see that all these sub-interfaces, they are subtypes of interface collection. And the interface collection itself is a subtype of interface iterable. The Java forces these types to be of subtype of iterable to provide that you can to get an iterator on these objects, and then from the iterator you can iterate, and you can, if you have like 10 elements, so you can cycle through and visit the different elements through the iterator object. And if you want to have your own kind of collection class, concrete class, then when you make a subtype of any of these collection interface or classes, it will automatically be inheriting the method of iterable, and will require you to provide with the iterator method. Okay, but this is just a snapshot. So this is not the complete list of all the classes and interfaces. So this is more like a selection of important and useful interfaces and classes in this framework. So, and these the classes are mainly in the package java.util. And as I told you earlier, that all these sub interfaces need to be subtypes of the interface iterable. So if it's an interface, you need to extend the interface iterable, and if you are implementing a class, then you need to implement this interface, and it allows you to use this iterator methods, and also the for loop, the for each loop. And then if you want to compare this collection versus arrays, it's as we know that if you in the arrays, we need to specify the size of the array when we want to, when you are creating the array object, but that's not necessarily in the collection. So you can instantiate collection without specifying the size, and the collection can grow and shrink in size dynamically depending on the values when you add or remove the values. But the important thing with this collection is that you cannot use primitive types with the collection. So collections cannot hold primitive type values. So if you want to put your primitive type values, you must need to use the wrapper classes. So the wrapper classes, these are the classes that Java API provides you to wrap the values of primitive types. And for each, we know that we have like 8 primitive types in Java. And for each of those primitive types, Java provides you with the primitive type, the wrapper classes. So for example, the integer, long, double, float, and byte and character. So So that, and then by using these wrapper classes, you can, of course, you can wrap your primitive types value in the wrapper class, and the wrapper class objects can be passed to the collection, because the collection works only on the object types or the reference types. They don't work with the, yeah, I'm sorry. I need to bring some tissues because I'm having some flu. Okay, and then moving forward, so here is some of the key interfaces. Yeah, and as we seen in the hierarchy diagram, so one of the root interface at the top, it's the collection interface, and it's the interface which specifies the core functionality required by all the collection types other than the map. So all other classes and must need to be are the subtypes of this interface except the map, and we will see why the map is not subtype, because it stores the values. It differs in its representation, and and this collection interface, it doesn't have any concrete implementation. Rather, it has a subtypes. And these subtypes these include list, set, and queue, and yeah, and these subclasses. For these subclasses, you can have the concrete classes, and these concrete classes are either implementing list or queue or set. So one of those interfaces. So the difference between list and set and queue is that list is a more like an ordered collection. And and you can use it if you want to have a collection which is ordered either in ascending or some specifics, and if you want to have sorting operations. So then you should use this list interface. But the problem with the list is that it can contain duplicate values. So and if you have a requirement that you want to have a collection of unique values that doesn't contain any duplicates, then you have to use the set. And the set, it's a collection without duplicates, but it doesn't maintains any order. So all the implementation classes of the set will have an unordered collection. And the third type we have the queue, and as you already know that the queue is opposite to the stack in general. That instead of having last in first, it gives you first in first order, and but that's a general recommendation. But there are some queue implementations which doesn't follow the first in first order. For example, the priority queue, it's instead of ordering the elements based on their order first in, means that if you will get the element that was first inserted, but instead of following the first in first order in the priority queue, you can order the elements based on their priorities. So you can assign the priorities, and the higher the elements with the higher priorities will be accessed before the elements that have a lower priorities. And then we have a map. It's like the map. You use the map when for those kind of data items. For example, in some kind of data items, we have some key associated with their values. For example, if you see that every book in a library have a specific key or an identifier that just to locate or search the books in a fast manner. And same is like every student maybe have a student ID, and maybe every person has a in a commune or in a social system of that where he lives. He might have from his local government or government, he might get some unique identifier as an ID. So if you have a values which have this key and value associations, so for these kind of values, the collection type that is recommended is a map, and we use the map when we want to associate keys to a values. And some of the rules with the map is that it cannot contain duplicate keys, because no two students in a class can have a same key, and same is like no two books in a library may have a same ID or key. But of course, I mean, the duplicate values are allowed. You cannot have the duplicate keys, but you can have a duplicate values, because maybe in a class you may have two students with the same name. So the values could be duplicates, but the keys must be always unique. And yeah, some of the implementation classes for the map include hash map and yeah, linked hash map. So we will look at these implementation classes later on. So here is yeah, the class interface diagram in a UML notation for the interface collection, and it shows you some of the key methods, and we will look at these key methods one by one. And these methods we can yeah, I mean, they can be categorized in four major groups. The first one group is like the add elements, and in these elements the methods are that you want to use elements in a collection. And the first one is the add element E. So it's as simple as the name says, that it adds the value, the input parameter E into a collection and returns true or false. If the item is successfully added, it will return true, otherwise it will return false. And then you have an add all. This you will use to add only one item, but if you want to add more than one item, like another collection, if you want to add one collection in another collection, then you can use this add all method, and this you can use to add yeah, more than one element. And the same, we have this remove. If you want to remove one object, clear if you want to remove everything. And sometimes you also want to remove one from one, as you can add one collection to another collection. Similarly, you can remove one collection from another collection, and for this you can use this remove all and retain all. Remove all will remove the elements, but only the collection elements that you have specified, and the retain all will remove all other elements, but not the element that you have specified in the input parameter. So that's the difference between the two. And then the collection interface also provides you some query methods that you can use to get information about your collection. So for example, the size of the collection, and whether the collection is empty or it does contain some values inside. And if you want to specify to get whether this collection contains a specific object or not. So, and then there are some other methods, and one of those is like iterator methods, and that you get to get an iterator. And arrays, if you want to convert your collection to an array, so that you can use two-array method. Then this is just an example of how you can use collection methods. So maybe we just look at, here we have some classes for them. And yeah, as I told you before, the collection is an interface, and we know that from previous lecture that we cannot create an object, we cannot instantiate an interface. We can only use it as a reference variable. So, but we can use any of its subtypes. Okay, so in this case we use the subtype array list, which is implementing this interface list. So the collection interface, and probably this array list is one of the most widely used collection classes. So, and we use, if you want to add these values, and here we use the generic syntax. We are telling that this is a collection of strings, so no other type of values can be added, and we are adding some continents just to give an example. And then we can use the iterator method to get an iterator and traverse on the different values of this collection. And we can use the remove method. That's just an example to convert a collection to an array of objects. And yeah, so. And then you can also use this add all method to add collection to another collection. So you can just play with this code. You will get this together with the lecture slides. And then moving forward, after the collection interface, we have, we know that the collection interface has three main interfaces: the list and queue and the set. So, and the list interface, we already learned a bit about it, that we use it to have an ordered kind of a collection. So if you want to sort, and but the problem with this is that it can contain duplicates. So and here are some of the methods. Some of the methods are the same like in a collection. So for example, the add and but this add, it will add the element at the end of the list. But if you want to add it, because the list interface is extending the collection interface, so the extension means that if you remember the previous lecture where we learned the concept of inheritance, and in the inheritance we said that when a class extends another class, it adds new features. So it's like a generalization and specialization relationship. We talked about that. So collection was more like a generalized form, and now we have three different specialization of the collection interface in the form of this list interface and set interface and queue interface. And each of these specializations have some differences according to the different specialization needs. And this list interface provides you with the method to add at the end, or you can add it at specific index if you want. And then you can also, this is the add all is the same as add all in the collection. And these kind of methods, they are also called like positional access, because we are using the index to access, to add or remove the elements. The set method you can use to replace an existing element with a new element. And and then you have a search methods. So if you want to find out the index of a particular element, and the difference between, since a list can have a duplicate, so if you have more than one elements with the same value, index of will return the first occurrence, and if you want to find the last, then you can use the last index. And then we can also get a sublist from specified index. So if you have a list of 100 elements, and if you want to get a sublist from element number 50 to 60, so you can specify those as a 50 as a from index and 60 maybe as a last index. So from to this index to this index, and you will get a sublist. And then we have this list iterator methods. We have two different overloaded list iterator methods. So one without a parameter, and another one is, so one without a parameter will return a list iterator from 0 from the beginning. And if you want, instead of from 0 to some specific index, you can use the other method. And the difference between a normal iterator and a list iterator is that in a normal iterator or a simple iterator, you can iterate only in one direction. So you can only move from start to the next. But in the list iterator, you can iterate both in the forward and a backward directions. So for example, the normal iterator, you have only the method like has, next, or next. But in this list iterator, you can have method like previous, and using those methods you can move in the backward direction. So it's just an example of this, and maybe we can look. It's more or less the same as we have a real example for the collection class, and we are using here the list, the element of type list. Let me see, maybe I'm missing, So here we have used the type collection, but here we are using the type instead list. And since list is again an interface, so we cannot create an object of type list. So once again we are using its concrete implementation, array list. And we have the same method, add all and add, and and then we can set, and then we can also, since we know that this list class provides us the sorting feature, so we can use this sort method to sort the values of a list. And so you just you will get this class as well. So you just see and try to use different methods and see what does it how does it behave. And so that was the interface. But then we have there are, I mean, more than these three implementations. You can see if you go to the, maybe if we just go to the Java Docs API, and if we look at here, or maybe we can, you can find it here like collection or maybe list, java.util.list, and here you can see all noun implementing classes. So there are quite many different implementations. So it's not feasible to look at all those classes, and so we will look at only some of the key classes. So, and these include java.util.ArrayList, and then we have a linked list and vector. These classes, I mean, the basic structure, the basic mechanism is the same, but then they differ in some of their features. So, for example, some are good from different performance point of view. And this array list, this is basically based on the idea of array, but it uses a resizable array. So it automatically, you don't need to care about the resizing. And the linked list, instead of using the array, it uses a linked list data structure. So if you have learned about the data structure, you will know that what the linked list is, where the elements are connected, the objects are connected through some pointer using a next. And it could grow. And it uses the doubly linked list, so which means that it has the linked list has pointers in both forward and the backward direction. Other difference is that since it's the array list is a array-based implementation, so the get operation or the search operation is quite fast. Its time complexity is this big O notation we use for time complexity of some data structure or implementation. So it's almost constant, and it's 1, so it's quite fast. But if you see this linked list, it has the slower get operation. Why? And its performance depends on the number of elements added into that collection. The reason is because the array list uses an index, and you can just provide the value of, and you can use the index to find that value quite quickly. But here you have to visit all the elements one by one until you find the elements. So if you are, it might be the element that you are looking is at the first, and you find it at the first time, so then it might be very fast. But if it's the last element, then you have to visit all the elements from 0 to 1. And then we have this vector class, and the vector implementation is mainly the same, equivalent to the Java array list. But the difference is that the array list is unsynchronized. What it means by unsynchronized, that if you have multiple threads in your program, and then you have more than 2 threads can access that code, and then you have to take care of that collection by yourself, that both threads are synchronized. So it could be like, otherwise it could be like both threads are accessing that collection at the same time, and if they are manipulating at the same time, you can miss some value or data ID. So, but you can, I mean, you can make this release implementation by synchronized by yourself. And but on the other hand, if you want to don't do that, you can use the vector, and the vector will make sure that only one, since it's a synchronized, so it will make sure that only one thread can access it at one time. And another difference is that array list grows by 50%, and so whenever, if you have like the size, if the initial size of array was like 100, but then if you are adding a new element, so it will have to resize, so it will add 50 more elements to it. But on the other hand, if you have a vector, so and if you want to resize it, so it will grow by 100%. So if it was 100, then it will grow by 100. So it's some of the difference between the performance. And because of synchronization, the performance of vector is normally lower than that of array list. And another feature is that vector is nowadays is considered as a legacy class, so it's not quite much in use. So it was kind of older classes and the classes that were used in the beginning of the Java, like the Java 2 or 3 to store different kind of values. But nowadays, you are usually either using array list or linked list. And then we have this set interface, and as we learned earlier, that you cannot contain duplicate values inside it. So, and if you try to add an element which already exists, so there will be no effect. So it will simply ignore the element which has been added already. And you can see some of the methods. And if you look at these methods, these are mostly the same as the methods in a collection interface. However, these methods, the methods which are used to add the elements, they differ in its behavior, because in the collection, there is no restriction for, in general collection interface, there is no limitation on the duplicate values. But if you are talking about the set, then the set doesn't allow duplicates values. So it means that the add methods and the add all method, they put some kind of limitations or constraints to prevent duplicate values. And to see what kind of programs or elements you can use the set. So as simple as that, if you want to make sure that there are no duplicate elements, go for a set instead of a list. And if you want to see that how many different words are there in a collection, so then you have to use this set class, and then you can find out. You can add all, as it says that you can add all those values you want to for a set and find out the size of that. But then the problem with this set is that it's not ordered. There is no sequence, and because there is no position. So whenever you get values or traverse the values, you can get the values in a random order or in a different order. And we have 3 different implementations for this, and same like the list. As we seen in the Java API that there are many different implementations. So same is true for the set. There comes a number of different implementations, but these are some of the most used implementations. Hash set, and then we have a linked hash set and the tree set. And the hash set, as the name says, it is implementation which is that uses a hash table. And what the hash table is, it's an array in which the elements are added using a hashing function or hashing mechanism. We will look at in a short while what the hashing mechanism is. And due to this hashing mechanism, its add, remove, and contains operations are quite fast, because you find based on the contents of your value, you find the hash code, and you go directly to the element that you want to add, remove, or yeah. So, but then keeping the basic feature of the set, there is no ordering. So whenever you try to print, you will get the elements in a different order, in a random order. And on the other hand side, the next class, the linked hash set, it uses both the hash table and then it uses the linked list. Same like sorry, the set uses the list, and then it has this add, contains, removes are a bit slower than hash set, but faster than the tree set. So it almost sits in the middle of the two. So if you want to have a more, if you have a performance specific application, maybe it's better to use hash set. Then the elements are ordered, but it provides you the advantage of using the linked hash set is that it provides you some kind of an ordering, and the ordering is normally the order in which the elements are inserted. So it maintains the elements, the order in which the elements are added. So if you add an element first, so you will get that element in first. So and then we have this tree set, and the tree set is backed by a binary search tree, and the binary search tree is a data structure that we use normally for our sorting of data. And but the problem with this is that it provides you with it allows you to order the elements using the comparable interface. And the comparable interface is a Java interface that allows you to compare your objects and it has a compare to method, which will return an integer value 0, 1, or -1. 0 if the two elements are same, if the two objects are equal, and if the object that you are comparing is greater than the element that you are comparing with, then you get +1. Otherwise, if you get a -1, then it means that the element that you are comparing is less than the one that with which you are comparing it. And here is how the hashing mechanism works. So let's assume that we have like the size is of our array is like n. We have like n buckets, and bucket is like we have something like we have position, and then we have the list where we want to store the values. And the hashing works as like this. It's take the value that you want to put in this list, and then on that value it compute a hash code or a hash value. So, and the hash value function, it uses a hash value function and it returns an integer value. So it maps your element that you want to put in a set or a hash set, and then for that element it gives you a hash code. And normally you get if you have a perfect hash function, then for each different value you will get a different hash code. And then you apply your hash function. And what does it mean? That you map hash value to bucket. So based on this integer value, if it's returned 1, you put the value at position 1. If it returns the hash code value 5, you put the value at position 5. Okay. So for example, if we look at the example over here, so if we have like a table with 64 buckets, so it means that if we have this table with the 64 position, so and then we can compute the value of the, and if we assume that the values are of type string, so it means like hash table for strings, and so that means that we can compute the hash value of the string element by summing up the ASCII codes for each character. And then to compute the hash code value, we will divide divide it by the size of the hash table, and the remainder that I will use the modulus operator, and whatever the modulus the value as a remainder we get, we use it as a position. So here is an example. If we're trying to add hello, and then we add the ASCII codes for each of the characters over here. For example, the ASCII code for H is 72, for E is 101, and up to O, we add all these, the ASCII codes for the characters here, and we get the value is equal to 500. And then to find out the bucket position, we divide this value 500 with the size of the hash table. So in this case, the size is 64, and this gives us the value 52, and this 52 value will we use as a position. Okay. So for example, if you go here, if you have a value like if the size is 10, then you get, at first you compute the hash value, and then you divide the hash value with the size of your hash table, and that will give you the position. So that means that we insert hello in bucket 52 if not already added. If it's already added, then we just ignore it. Or also sometimes it could be a collision. And do someone know about the hash collision? What is the hash collision? Sometimes it could be possible that sometimes you might have two different values that end up with the same hash code, and in that case that kind of situation is called hash collision. But Java, these collection classes, they automatically resolve this kind of collision. But in order to know that how you can resolve a collision, maybe one way is that to resolve the collision on this hash table, if for example you have two different values which has position 4, so you can store those values as a linked list. So you add a first element, and then you add a pointer to that element in that element. So you can store them as a, instead of just having one value, you can store them as a linked list. And yeah, and all objects in Java, they are already prepared for hashing. So it means that the java.lang .object class provides you with the equal method and the hash code methods. So, and we know that object is the super type. So it means that all classes in the Java that you define or create will have these two methods. And also, I mean, how can we use these two methods for the hashing? We can use the hash code to find out the hash value. And we can use this equals method to find out if the two objects are the same, identical or not. And there is also some rule about this equals and hash code. It says that hash code must always give the same value when called on the same object, number of many times. So it should not be like if you first time if you call a hash code value or hash value and then it gives you hash value 10, and if the next time you call the same object, it should always return the value 10. Otherwise, your hash code is not correct. And the other rule is that if the two objects are equal, if O1 is equal to O2, then the hash code of O1 must be equal to the hash code of O2. So but on the other hand side, if two objects have the same hash code, it doesn't necessarily that the two objects are similar. Okay, understand? The difference is that if you have two objects according to the Java's rules, if the two objects are equal, they must have a same hash code. But on the other hand, if the two objects have a same hash code, they can be different. It doesn't necessarily that they must be equal. But if you have a very perfect hash code function, then you can get unique hash code for each object. And then if you have like hash code is the same, then you can say that both the objects are equal. Next, moving forward, we have this queue interface, and in the beginning we looked at a short overview of this, that we use this interface to hold elements similar to the concept of a queue. For example, a queue in a shopping mall, or a queue in a bank store, or maybe in a library to get the books. So it's like placing the elements in a queue before processing, and the general order is that the queue elements are stored or accessed in the first order. However, there are exceptions. For example, the priority queue, and you can also implement a queue in the last in first order. And if you do that, it's more like a stack, not a queue. And the queue interface methods, if you see here, they are mainly divided into groups. The first group is we call them throws, exception, and the other one is the special values. And the difference between them is that the throws exception is if there is some problem, and if the operation fails, it will throw exception. On the other hand, the other one will not throw the exception, but it will return a special value, either null or false, depending on the operation. Yeah. And we have and these three operations here and these three operations here, they basically are performing the same operation. The only difference is that the methods in this group, they throw exception, and here they throw, instead of throwing the exception, they return the special value. The add element, yeah, you use it to insert the element in a queue, and remove, yeah, it will return you the element and also remove that element. But if you look at if you don't want to remove, you just want to get an element or see an element, then we use the element method instead. And these are the equivalent of these three. So the offer is used for the inserting the element, and the pool is just to peek is just to look at, and the pool is to get and also remove at the same time. Moving forward, the next we have the final interface in today's lecture. That's the map interface, and the map interface is used to specify the collections that maps that have a key value association with them. So as I told you in the beginning, that if you have some kind of for example, if every book in a library has a key, every student has an ID, so this kind of associations, if you have, then we use the map to map the values according to their key value pairs. And that's why if you see in the map declaration, you have this K and V, the two pairs. K is for the key and the V is for the value type. And each key value pair is known as one entry in a map. And and the key object is used to store and retrieve the values. And map cannot contain duplicate keys. Key can map at least to one value. And if we look at here in the beginning, in this, so here we don't have a map class or interface because it's not a subtype of collection, and it doesn't implement or it doesn't subtype of iterable. So which means that you cannot get the API methods defined to traverse or visit the different elements. You cannot use the iterator method. You cannot get, there is no iterator method which returns you the iterator object. If you look at these methods, so there are different methods like put and clear and remove, but there is no method to get an iterator. However, you have this key set and entry set and value set method, which returns you this method entry set. It returns you the whole set, the whole map, and here the key set, it returns you only the set of keys. So and from this set, you can use these set objects to visit the values of the map. So if we look at the map methods, they are more or less can be classified similar to the collection interface. So we have the methods in the category add, and you can use this method to add values. And then we have the remove methods that we use to remove the entries from the map. And then we have these query methods that we can use to get information about a map, if it's the size of the map and whether if there is if a map contains a particular key or not. And then we have this providing collection view methods that I was talking about, that although you don't get any it doesn't implement the iterable interface, but you can use these methods to get a set view. And as we know that the set, the return type here is a set, and we know that the set is a subtype of collection, and collection implements the iterable interface. So that's why we can use from this, the object that you get from here, on that object you can call the iterator method, and that iterator method will return you the iterator object. And the map implementation, some of the important implementations for the map are like hash map, and it's again using the hash table, and we already looked at the hash table in the hash set implementation. So but then some of the problem with the hash map is that there is no guarantees about the iteration order. The order may change over time, and unlike the hash table, which is another class in the Java collection, and hash table doesn't allow you to put the null values, null keys and null values, but you can put even the null values and the null keys in the hash map. And another feature of hash map is that it gives you very constant performance when you for the its put and get methods. And the reason is that and that will work only when all the elements are equally distributed in the map. Otherwise, if you have like elements distributed on one side or another side, so then maybe the performance of the get and put might be not constant. And it's almost same equivalent to the hash table. The only difference is that, as we tell here, that hash table allows the null values, hash map doesn't, and hash table is synchronized, but hash map is not synchronized, but you can do it by yourself. And linked hash maps, yeah, it's both. In here we use array or hash and hash table, and we know that the hash table is more like an array. But if you look at here, it uses both the hash table and linked list implementation of the map interface. And the difference between hash map and linked hash map is, in the hash map, there is no order guarantee. You get the elements in a different orders. But if you are using the linked hash map, you will get the iteration order in a specific order, which is the order in which the keys are inserted. It's almost same like as we have in the linked hash set, and also it maintains the doubly linked list running through all of its entries. So the two differs in their ordering and in the structure. And then if the last one in this the implementation class for the map interface is the java.util.tree map. It uses a red-black tree-based implementation, and red-black tree is another data structure. It's a kind of an advanced form of a binary search tree that we use for sorting the elements, and it sorts the map according to the natural ordering of the keys. And for the natural ordering keys, it uses the comparator method, and the comparator method is comparator object, and the comparator object is it's more or less similar to the comparable interface. But the difference is, in the comparable interface, if you can implement it and override the compare to method to compare the two objects. But if you are using the comparator, you can implement it outside the class. And but if you want to use the by default, you will get it will use the comparable interface, and it's compare to method to compare the objects and order the objects. But if you want to use the comparator, then when you are creating the object of this tree map, you can provide the object of comparator as an input parameter in the constructor method. And and the tree map is recommended when you want to iterate or sort the keys that are stored in a particular order. So remember that the sorting will be and iteration will be on the keys and not on the values. So it will sort the keys, and then the values will be sorted according to the order in which the keys are sorted. So this brings us to the end, and here are some of the links and some chapters. You can almost all the textbooks cover this Java generics and collection framework topics, so you can look at. And maybe you can also find it in the previous book, the Java Complete Reference. But this book provides you more detailed, and then there are some online links. So you can look at them, and if you have a question, of course, you can ask me now or whenever you want, or maybe you can post it on a Moodle. And and in the next lecture, which will be on Tuesday next week, not Friday. So in that lecture we will learn about exception handling and unit testing, and that will be our last lecture in Java. And after that we will I think we will start with the data structures and algorithms. Okay, so bye for now, and welcome for the questions.
Sir,
Yeah.